Welcome to homework.
So we need to answer some questions about this molecule. A, where are the stereogenic centers? We'll label them with an asterisk. We only have one, which is at this tertiary carbon. You may want to mark the nitrogen as a stereogenic center, but because it can flip back and forth, we do not consider it a stereogenic center. B, what amides can be reduced to form this product? So we can only have one type of amide that can be reduced. And it's going to be this position here. And sorry, I was actually mistaken. We can have another one, which would be the formamide, having the carbonyl group at this position. Let me just redraw. Because again, we need at least two hydrogens on the carbon adjacent in order for us to have started from an amide and then gone through a reduction to get to this amine. C, what carbonyl and amine can be used to make this product by reductive amination? So for the reductive amination, we can have this bond have been formed, this bond have been formed, or this bond could have been formed through reductive amination. I'll label this pathway A, B, and C. So for A, our amine would have had to have all of these carbons already attached. And we had to have reacted with this aldehyde such that the nitrogen can, of course, form the amine and then be reduced to this primary or tertiary amine, excuse me. For B, the left-hand side is now a carbonyl, but in this case, instead of being a aldehyde, it came from a ketone. And our amine has all of the other carbons, such as this N-methylbenzylamine. And finally, for C, our nitrogen contains both of the aromatic systems, and we simply need to react it with formaldehyde under aminating or reducing conditions to get to the reduction. D, what products are formed by Hofmann elimination? So if we draw this, of course, for the Hofmann elimination, we first need to get to this cation, the hydroxide base. So under heat, this hydroxide base can only deprotonate one carbon. Can you see it? It has to be the beta position. And so we actually only have two beta hydrogens, which are here and here, right? So that's one carbon, 2 carbons away. These methyls don't have any other carbons. Moving to the right, we would be on this quaternary carbon. So that makes our life a fair bit easier. We can only deprotonate one. And so we will generate either the trans beta-methylstyrene or the cis beta-methylstyrene, and the NN-dimethyl benzylamine. Of course, water is removed as your conjugate acid.